rule is a way to solve limits using derivatives. Okay, it's something that is pretty straightforward and something that we can use pretty easily. Okay, so the first thing that you'll want to know is that any limit must be in this form. Okay, so it has to be rational. Now we can manipulate, there's the word, we can manipulate a lot of limits into this form to use L'Hopital's rule if we need to. Okay. So that's the first thing you need to know, is it has to be in a rational function, and the result must be an indeterminate form. Okay. So you do your plug and chug as always, right? We're cycling through our limits knowledge again. First thing you do is plug and chug. If you get an indeterminate form, like previously we would say try algebra, right?
Yeah.
Well, now you can try L'Hopital's rule. Okay, so you have some options. All right? So if that happens, dude, I haven't even. What?
We're at normally solving this shape at some point.
Hey, Mr. Ruff,
Normally solve?
Yeah, like that.
I'm sorry.
do you have a Band-Aid?
Lots of Band-Aids.
Can I have one, please?
Okay, so if this is true,
No, please.
we can use derivatives. That will give us the same answer as the original functions. Oh, it's snowing.
Thank God.
At least it's not raining.
Hopefully it snows now. Cover the roads.
Huh?
Cover the roads.
Yeah, please don't. I have to drive out in the middle of nowhere. I don't want to drive on snow. Thank you.
Let's maybe. Okay. Let's write this how it properly should be written. So the limit is the same as the limit of the derivatives of each. Okay? So we can calculate the derivative of each function, top and bottom, and we'll probably get an answer, and it will be the same answer as the original. So that's kind of clunky. Okay, so when you see a quotient and you see derivatives, what do you usually think? What rule do you usually think? Yeah. We don't want to use the quotient rule here. Okay. So this is actually easier. Okay, so just make a mental note here. If you're using L'Hopital's rule, do not use the quotient rule. Okay. You just derive the top, derive the bottom separately. Right. So now that I've spoken enough. Blowing me up. All right. That is a 2. X cubed minus 8.
Just doing that on top and bottom.
No.
Checker.
You have to see. You have to try it. Plug and chug it first, right? So plug 2 in. What do you get?
Probably 0.
Hope so. 2, 4, 8, 16 plus 4 is 20 minus 20 is. So you have an indeterminate form. Okay, good. You always have to check that. Okay. Now you could think about using algebra, but I don't think there's a factorization for the bottom. Right, I don't think the bottom's factorable, so.
Yeah, I know.
But you can use L'Hopital's rule. Right, so I always note that I'm going to use it. And then rewrite. The limit as x approaches 2. And derive the top. 3x squared. And derive the bottom.
4x cubed, third,
Plus
yeah.
2.
Now plug and chug
I
again.
said cubed, you said third.
Pretty simple, right? Just like everything else in calculus. It's so easy. You disagree?
Yeah. I do disagree.
What do we get? 12 over
Oh goodness.
34.
Oh, that's actually not that bad.
And we can reduce that, right?
Mhm.
I believe so.
There's your answer. Done.
Oh.
Oh wow.
So is this an alternative for solving zero?
So solving it
Yeah.
algebraically.
Algebraically?
Yeah.
This always works.
It's another option. If you have an indeterminate form, I'm not going to guarantee that it will always work,
Mm.
but
And,
it's an option.
How do you know it's rational? What does that mean?
It's a fraction.
Oh, that's it.
Rational number is a fraction, a rational function. I'll show you one where you can manipulate it if you want into a fraction. Okay, let's see. Let's try one with a trig function.
Of course.
How about that?
Of course. Let's go for it.
You know what I'm saying? It's always been easy. They just get swung some.
I actually wouldn't mind this one. What does that say? Is that sine pi x?
Uh-huh.
Okay.
Yeah, okay, thank you. What's the top?
0.
4 minus 4 is,
0.
and what is sine at 2 pi?
0.
0. You could pray for the pre-calculus class to get their unit circle lesson today.
Oh, poor them.
And then it's the never-ending unit circle quiz every 3 to 4 weeks.
Oh yeah,
For this.
that was great.
Okay, so we've determined we have an indeterminate form. So now we've determined that we can use L'Hopital's rule to determine the answer, right?
Yep.
Okay.
Derivative of the function
It's also rational.
No,
negative
It's not?
not what?
Oh, you said no when I said rational.
I wasn't talking to you.
Oh.
The whole world is not
Yes,
revolved
it
around you.
does. My
Don't
dad
know if you
says
knew
that.
that.
My dad says that, and I'm like, yeah, it does. I'm your son. Get it?
S-O-N?
Yeah.
Learn how to spell. Which proves our point even more. Thank you very much. All right. Derivative of the top
Negative 2x.
and the bottom.
cosine.
Yeah, say it. You got
I
it.
don't know, cosine pi x.
Hey,
Yeah.
Plus.
chain roll.
Oh.
It's a chain roll.
Oh.
What's the derivative of the inside? Pi.
I was like, I don't know.
Yeah. Yeah, don't forget that chain roll. All right, now you can plug and chug again, right?
Uh-huh.
So we get negative 4 over pi times cosine 2 pi. See what he says?
Survey says I don't know.
Stop it. This was Family Feud, they'd be like, what's the cosine of 2 pi? I don't know would be the most popular answer.
Yeah.
What? Cosine 2 pi is 1, so you get negative 4 over pi, and you are answer happy.
Yay, answer.
Question.
Yeah.
Could you just leave it the step before?
Could you leave it the step before?
That,
Yeah.
not acceptable.
Dang it.
There's still a function in there, it's not, see, you still have a function,
Yeah.
so not free response friendly. You have to, it has to be completely numeric. They did add this to the AP exam last year. Okay, so
Woohoo.
this wasn't an AP calculus required, I always did it anyways, but it wasn't required before last year.
Do you
So
think they'll
it is
put it on
very
this year?
possible they'll test it again in a free response. Okay, so just have that on the back of your minds. All right, shall I show you one?
That doesn't work? Yes.
-1? So none? We're done? All right, thank you, Kellen. I can show you one that's not a fraction
Yeah, that might be helpful.
right away, but it becomes one when you manipulate it.
Do that.
Okay. Why is it from the right? Why is that 0 from the right?
Because that can never be zero.
What can never be 0?
Notice.
Yeah, natural log is no, 0 is not in the domain of natural
Nope,
log, right?
natural log
Okay.
can never be zero.
So what is the answer if you plug it, Shug?
Zero.
I'm willing to that.
It's 0, but what's natural log x as we approach 0 from the right?
Infinity.
Not infinity. Keep in mind that the graph looks like this.
No, it's negative.
Right. Is that an indeterminate form?
Yeah.
Yeah, it is. Okay, kind of a funky one. So how would I make that a fraction so that I can use L'Hopital's rule?
Oh my
Think
goodness.
about it algebraically. What can I do to one of those to make it a fraction?
Divide x.
What?
Ln E.
Not even that complicated.
Natural log x over x to the negative first.
Yeah, that's
Okay.
what I was saying.
Did I just not hear you? Or
Yeah.
did I ignore you?
I don't know which one you did, but
I'm pretty sure I didn't hear you.
probably.
Too many years in the wood shop lately,
Yeah,
and too many years of loud music in the past. There you go.
solid.
Yeah, so you can manipulate that exponent. Right? Now we can use L'Hopital's rule. And what's the derivative of natural log?
E.
That's the inverse. 1 over x. Thank you, David. We're putting faith back in. The math teacher. And the derivative of x, the negative 1.
Negative.
Negative square.
Negative squared? Negative squared? When have I
Negative
ever
squared.
said that? About 2 seconds ago. Okay, fine.
To the negative.
Thank you.
Negative square.
You just can't make crap up.
Why not?
Actually, you can. You shouldn't.
Yeah.
All right, so
It's way better.
rewrite. It'll make it a little bit easier. Right? Now, can you algebraically manipulate that?
Well, I believe so, yes.
How do I simplify that algebraically?
Well,
Two exponentials or exponents that are divided, what can I do with the exponents?
Subtract.
Say that louder.
Subtract.
You subtract the exponents.
Smart.
Remember? So that
Yes.
exponent. So -1 minus -2
One.
is 1. And we now plug and chug again and we get nothing. All that work and you got nothing. That sucks.
Woohoo! Why is that my way?
just sucks. Right?
Potato chip is
Okay, let me show you two more.
Wait, so 0 plus the-
You eat it.
No, it's the answer.
You eat it. Why do you want me?
So,
Oh, it's
remember,
always approaching 0.
right, remember, this is a y value. So this function is approaching 0
There's personality.
as x approaches 0 from the right. Okay, so, all right.
Oh, goodness.
Let's see.
Oh, no.
Oh,
I'm down.
I'm new.
he's got a case of the Fridays.
Mm-hmm. I always do. I was debating on that.
It was forced upon us.
It was
So you plug in 0, you get 0.
Do ya?
Well, I don't know.
Sure.
We're about to
No.
find out.
You just don't assume you're gonna get an indeterminate form just because we're studying L'Hopital's rule.
And you don't in this one.
1 minus 1. So
1 minus 1, 1 minus 0 minus 1 is 0. Cosine 0,
It's 0.
it's 1.
Oh, it's 1.
1 minus 1 is
Yeah,
0.
that's
Okay, fine. You win.
I thought it was 0. I'm sorry.
You're better.
I am better. What?
You have a test in Spanish.
Yes.
I literally
Right.
haven't done it all week.
What's the derivative of the top? Easiest derivative we have. Okay. Minus. Okay, and somebody says that the derivative is negative sign. Somebody. Hopefully somebody I can see. Seriously? Yeah, I forgot to take attendance. It's really fine. Solve that.
What's 0?
Yes, yes.
0? 1. 1.
Uh-huh.
Yeah, because it's 0 all over. Negative sign to lose 0 is
Sign to 0 is 0.
negative sign.
Okay, we need to finish, because I have to take attendance. Okay, what'd you get?
I still got 0 over 0.
Uh-oh.
Yeah, I still got 0 over 0.
Now what do you do?
Skip.
Algebra.
So then determine a form, right?
Yes, skip it.
Okay, what do you do?
Oh, is now where you factored?
That's a really good suggestion. Let's try that.
Do it again and get the same answer.
Do it again.
Wait, you need a second derivative?
E to the x.
E to the x of negative cosine x.
So then that's 1 over what? So that's
1 over negative 1.
so it's,
Andrew, good answer.
So if it doesn't work, just keep forcing
Yeah,
it.
you can keep doing it. If you continue to get indeterminate forms, you can continue to use L'Hopital's rule. Okay. Be careful, because if, the other one I wanted to show you is, sometimes you don't get an indeterminate form,
Oh,
right?
yeah.
Okay, so you can't use L'Hopital's rule.
I need
So
to-
just make sure that happens before you pull the trigger on L'Hopital's rule. Got it? Very nice. You do your work, and then hopefully you can finish it.
Woohoo! Because I have a lot of homework. I already have to write 2 essays.
And so you can study for your test.
Same.
I have to write 2 essays. One for my college, both for my college classes. One for my nursing class and one for my English class.
4, I think.
Huh?
It's 4.
Don't 2. One for my English college class and one for my nursing college
Well,
class.
I thought you said 2 for your English and then 2 for your...
You're like, what?
Jeez, chill.
Here you go.
It's not like I chose this life.